Hey everyone, I'm Travis, and in this video you're going to see me build this custom fuel cell. Enjoy. So we start out with a good old drawing on the chalkboard like everything does, with some simple measurements and simple calculations. I did more calculations than I can count to figure out the capacity and the size and the shape and all that kind of stuff. This video is going to focus more on the fabrication side of things and less on the gadgets and doodads that kind of come with an aluminum fuel cell. There is another video, a sister or brother video, depending on which way you swing, attached to this somehow. But yeah, anyways, moving on to the annealing process. This is something that is kind of the focal point of this video, how to bend aluminum. This is 1/8 inch 6061 aluminum, and I was able to bend it into some round corners. How did I do that? Well, you put down the black soot, and that black soot acts as a temperature gauge. I'm not a pro at this, so don't take my words to gospel, but this is kind of how I learned and how I know these things. Once that is done, it heats up to about 600-ish degrees. That's when the soot burns off and you're able to bend this thing. It kind of allows the molecules to get a little loosey-goosey, get the party going, and then you're able to move it, make it malleable, make it flexible, and kind of make things happen. This was the best method I found to bending it, believe it or not. Yeah, that's me hitting it with a hammer, clamped down to the bench. More on that in a second. I tried by hand, I tried with just different ways. I tried some ways I wasn't proud of. I think I tried some ways that aren't legal in all 50 states, but I ended up finding it with the hammer was kind of the best way. There's down and dirty, and I think my girlfriend's gonna be jealous about that one. But anyways, decent bend. I did some calculations on how much it was going to grow and the radius and things like that. I know that sharp corners aren't ideal with aluminum, so I decided to avoid them. You'll see this tank is built up of two pieces, a top piece and a bottom piece, or side piece and a top piece, or whatever, depending on how you look at it. But avoiding those sharp corners was kind of the idea, and showing off more annealing here. So as I said, heating it up, the panel will dance, get a little loosey-goosey, and then go into the malleable mode, let's say. You can do this over and over again. I do know that. I don't know exactly when the annealing stops. I don't really know where that line is. But you can do your own research on that one. Let's have a listen in here. So anybody that knows baseball, please rate my swing here. I was swinging for the fences on this one. I was hitting some dingers, so it was a bit of a barbaric and brute process, but it did work. I was a little worried about stressing the aluminum, kind of overstressing it, but it did end up working. And I think with it all kind of competing angles and kind of the way it's all held together, I think it's going to work pretty good. So I'm trusting it with about 90 liters of fuel, so I guess it has to work. But anyways, moving right along, I built some baffle plates. These baffle plates, although being that they control the fuel, they also hold structure to the tank. So one on each side, they kind of overlap and fit together, and kind of hold the tank together. So after a little bit of fitting, it was time to weld. As I said before, I'm not an aluminum expert. This was a learning experience for me as far as the aluminum went. And the welding process was a bit of that. So I've done a little bit of aluminum, but I'm definitely not an aluminum welder or anything like that. I don't claim to be. It did work out pretty good. The better it fits, the better it welds. And if you kind of follow your golden rules of welding, it kind of worked out. It was kind of happened. So made some cutouts for the fuel sender. I'm using the Holley Easy Level Fuel, or Easy Fuel Level, or whatever you call it. But that just shoots a laser beam down into the fuel instead of using the mechanical floats and all that stuff. It won like best product in the whole world or something a few years ago or something. I don't know, but you have to do your research on that. But it ended up working out pretty good. So here's another shot of those baffles holding things together. We go into a little bit more depth on the extra features episode, but that's for you to decide if you want to watch or not. This is fabrication, sticking to the fabrication. Speaking of which, this was the filler neck or filler rod, or not filler rod, filler neck. For it. So I didn't want just a circular hole. I wanted it to be able to flow the gas in and kind of let it fall as it may, as it does. You don't want to have you don't have any backup or backlog or bubbles or anything like that. Well, the bung on the left there is a vent for the filler tube, and the hole in the background is actually a vent for the whole tank. I ended up using a like a stock Ford rollover valve, kind of simple and easy to install and common product. They were used for like 30 years or something. So again, more stuff on that. Features, this is more the fabrication. So I was quite proud of this tank. Like I said, I didn't, not much of an aluminum expert. I hadn't really done much fabrication with aluminum, and I was proud of how this turned out. It did, you know, kind of bubble and warp a little bit and crown a bit, but I mean, look at that thing. It's pretty awesome. The bottom is tapered to let all the gas kind of head to the front, and you can see all the kind of the round corners came out together nicely. There shouldn't be too many stress points. It's mounted in a pretty stressless way, let's say. And the welds and all that turned out pretty good. I'm gonna run a sealer on the inside. I know some guys don't like sealers, some guys do, but I kind of like it. So yeah, that was it. Thanks for watching. Hope this helps somebody, and take care. See you at the next one.